Good morning, everybody. Let's start our discussion. Let's continue our discussion about the classes and their constructors. Remember last time when we started talking about constructors of the classes, we said that constructors are member functions of classes, but they are special. Why are they special? Because they are used for initialization of the objects. They are called not by yourself, but the compiler. Compiler calls them when the objects are created, and they are called exactly once in the lifetime of an object. For each object, the constructor is automatically called by the compiler. Since it is called during the creation of the object, it's a very good place to initialize your objects so that your objects do not have any invalid data in them. That's what we said last time. It's a very useful tool, and all the object-oriented programming languages, they provide a constructor mechanism for the initialization of the objects. When we say initialization of the objects, it is not done automatically. Initialization, it is done by means of the constructor, and you are writing the constructor, and you are free to do whatever you want with the constructor code. But usually we follow the object-oriented word rules, and we do our initialization with the constructor. Okay, so we said that it is written like a regular function, but as we know, a constructor should have the same name as the class. That's one difference from a regular member function. The other one is it doesn't return anything. I am not saying it doesn't return, it returns a void. I say it doesn't return anything, not even void. Okay? So a function returning void is a regular function. It returns void. But this one doesn't return anything. And this was one of the first examples that we have seen for a constructor. And then we have seen a few examples. Day of year class. You remember that, right? We have seen it. And we said that the constructor itself cannot be called on the objects. Okay, this is not legal. It is illegal. You cannot do that. Okay, it cannot be called. It is called by the compiler. And what did I say before? Usually inside the constructor code, we do the initialization. So I take these two parameters and assign them to our member variables of the class, month and day. Okay, that's what I do inside the constructor. But usually this is not it. I mean, it looks like we are doing the initialization. We do some other stuff in the constructor too usually. What do we do with the constructor other than the initialization? Other than the initialization, what do we do with the constructor?
Test.
I think Attackant said something. He said just test, right? Validation. Yeah. Validation is something that we do with the constructors. Because, I mean, when I say I like to have a day of year object, D1 with the parameters 100 and 107 and 73. Okay, I don't want to have this kind of an object. Month is 107, day is 73. This is not a valid date, day of year. I don't want to have these kind of objects. This is invalid. This should be invalid. But with this kind of code, there is nothing for my user to have that kind of an object. So this is not a good kind of code. In our constructors, we should always have code for checking for validity, if the dates are valid or not. Okay, so other than the initialization, we should look for valid initialization. And remember, this is a better way of initializing our stuff, using the initialization section after the constructor code. Okay, constructor header. This notation is valid only for constructors, not the regular member functions. This is only valid for constructors. This is what we said last time, and whenever it is possible, we are going to use it that way. Okay, good. Okay, validation the data is a powerful object-oriented programming principle. Like any other functions, you may overload your constructors, and we have seen examples of it in our day of year class. Remember, this was the day of year class, and I have 3 constructors, overloaded constructors. Okay, overloaded constructors, and this one doesn't take any parameters, 1 parameter and 2 parameters. It goes like that. And you may overload your member functions, or you may overload your constructors, no problem, as long as their signatures are different. Okay, so this was one example. I think we have seen it, and we said that constructor with no arguments could be confusing, because I mean, usually you want to use a no parameter constructor, no argument constructor, no parameter constructor like this, without any parameters. But if you do it this way, the compiler gets confused. That's why we don't do it that way, we do it this way. Okay, we don't do it that way, but we do it this way. Okay, by the way, when you say integer I, so this is an integer declaration I, you may use this notation 7. So it looks like the integer class has a constructor that takes a integer as a parameter, right? So this is possible with C++. I mean, this is the same as saying integer I, the initial value is 7. Same as this. Okay, good. So explicit constructor calls, again, I mentioned it last time. I don't like this. Sometimes people use this for initializing, changing the values of the member variables, etc. But I don't like it, because this is creating another temporary object, which is inefficient. I don't like it, as I said. So we talked about the default constructors. We said that what happens if I don't declare and implement a constructor for my class like we did before. Okay, the behavior of C++ is this: if you don't declare and implement your constructor, a default constructor will be implemented for you by the compiler. It is auto-generated. Okay, if you don't define any constructors at all. Okay, if you don't define any constructors at all. But if you define a single constructor, then there is no auto-generated default constructor. Okay, there is no auto-generated default constructor. Let's say I have a class. Let me do this. Class, and the name of class is my class. Okay, name of my class is my class, and public, I have function f1, and in private I have just a simple integer. That's it, very simple class. Okay, with this class I did not define a constructor, no constructors. So for this class there will be a default constructor, a default constructor. This default constructor will not take any parameters, okay? Will not take any parameters, and this default constructor will be called always by the compiler when you make declarations of objects. For example, when you say, I need this object 1 and object 2, okay? I created two objects, object 1 and object 2, and for these objects the default constructor is called. Default constructor will not do anything. It will not initialize this integer I, okay? It will not initialize that integer I, and we will talk about these default constructors later. We will talk about these default constructor. We will talk about these default constructors later when we have other stuff. Let me make a copy of it and let me do this. If I don't, okay, if I declare a constructor, if I declare a constructor like this, let's say my class, okay, I'm defining a constructor, and let's say this constructor takes an integer k. Let me implement this just in this class definition. I am going to implement this function. I will say the value of I will be, okay, that's the whole implementation. Oh, I forgot to put a return type for here, right? Integer and integer. Okay, so there will be no default constructor for this class. Okay, no default constructor, no def constructor. Why? Because let me rename this class, my class 2, so that I don't make any, I'm not confused between my class and my class 2. Okay, let me try to declare objects of my class. Okay, when I say my class 2, let me use different object names. Okay, v1 and v2. I cannot say v1 anymore because it needs a parameter 7 and 5. It will be that way. Okay, if I say my class 2 v3, this will be a compiler error. Why? Because my class constructor takes a integer parameter. My class 2 constructor takes an integer parameter, and this one doesn't give any integer parameters. I need to do it this way. These kind of classes where there is no parameter constructors. Okay, with these kind of classes I cannot say this. Okay, let me do this. Let me write it down here. My class okay. When I say my class object array 10, this is okay. I can have a array of my class, but I cannot have array of, I cannot have an array of my class 2 the array 10. Why? Because for each object of this array, the default constructor is going to be called of this class. Okay, for each object of this array. But for this object, for each object of this array, there is no parameter constructor. Okay, so I cannot have an array of such a class. Okay, so these kind of things. Okay, this slide is very important slide. It is important to understand this one. Okay, the meaning of default constructor. Default constructor is the constructor, okay, that is created by the compiler, and it is only created if you do not declare a constructor yourself. And the default constructor doesn't take any parameters. They don't take any parameters. Okay. If you like to have a constructor that doesn't take any parameters, you may declare it yourself, but that doesn't become a default constructor. It is called a no parameter constructor. Okay. So there was a question before, and I think it got erased. Oh, that means that I answered it. Okay, good. Okay, another questions. So Anil, what was your question? Just, I mean, I like to answer your questions, not just because you just asked them, because, I mean, many people have the same question, and sometimes people are shy to ask it. Sometimes they don't say it. So if you define a constructor with parameter and don't define a default constructor, then we will get error. Yes, exactly. Yeah, that's what I was saying. So what Anil is saying correct. And if you didn't catch that, if you did not understand that before, that's important point. Okay, that's not, you are not going to do it. Other than that, Anil, okay, other than that, my class object 1 will not be, well, in that case, in my case, it's going to be my class 2, my object 1, right? My class will work, but my class 2 will not work. Other than that, your array is like this. It is important that this one will work and this one will not work. And it is important to understand why, because this one needs to call, I mean, in C++, in any object-oriented programming language, if you create an object, a constructor has to be called. There is no exception. Okay? There is no exception. If you are creating an object, if you are making a new object, a constructor has to be called. I am creating 10 objects here. So what kind of constructor I am going to call? A constructor with no parameters. Well, which one is that in this case? It is the default constructor generated by the compiler. How about this one? Well, this one, there is a single constructor, and that constructor needs a parameter, an integer parameter. So how am I going to call those? Because it needs the integer parameter. In this case, since there is no parameter constructor, I cannot make this array. Okay. Burak has a question. How can we define an array of class which has defined a... Well, if that's your intention to make the arrays of your objects, if that's your intention, then you will provide another constructor here that doesn't take any parameters. Maybe you could do this, just a trick. Maybe you just could do this. Maybe some of you just guessed it. What am I going to do? K1. Okay. I provide the default argument. Okay. I provide the default argument. In this case, that would be possible to make arrays of this class, because this class can have a constructor with no parameter now, right? Can we create my class object in my class? No. Well, we will talk about it. We will talk about, because in your class, you may not have your objects of your class. You may have pointers to your class objects, but you may not have any objects of your class. We will talk about it today. That's an important technique, actually. Okay, let's move on. Last time I gave you some examples from the book, right? The bank account was a very nice bank account was very nice example. We like that. Well, I didn't like it much, but it was a good start. It said that with the bank account, with the private part, I am keeping all of my data as with 2 integers and a double, account dollars, account cents. Okay, account dollars and account cents. And then I have my double rate. Okay, these are the 3 things. And then I have all of my constructors here. See, I have a no parameter constructor. This one is my line 22 is my no parameter constructor. So I can have arrays of my bank account objects and very nice set of constructors. Okay. By looking at the constructors and my public functions, I don't know how I keep my bank account information inside my objects. Am I keeping a double? Am I keeping integers, etc.? Right? I don't know, and I don't have to know, and I should not know. That's the nice thing about object-oriented programming. I can hide, and I should hide this kind of information from the customer of my class. That's called the information hiding, right? That was one of the principles of object-oriented world. Information hiding. Hide as much as possible. Anything you can hide, just hide it. Okay? So the user doesn't have to know about it. We are not hiding our information just because we are jealous or just because it is for security, etc. We are hiding it because the user doesn't have to know about it. If I don't hide it, then that makes it difficult to use that class. That makes it difficult to use that class. Usually in C programming, we don't have that principle. In C programming, we don't say information hiding. Remember in C, how does the character arrays work? Character arrays or C strings. In C strings, we say that it's an array. Let's say I have a 3-element string at the end. I have null string at the end, right? Null character at the end. This is the detail of how I implement my strings in C. And this null character, I always have to keep it in mind, which makes it difficult to use this class, this data type, C strings, because I need to know about the implementation. But in C++ strings, okay, all I do is I just do this assignment, A, B, C. I don't care if there is a null character or if I need if I have the enough space. If I don't have the enough space, can I compare that? Okay, all that kind of memory allocation and the null characters and etc. are hidden from me. That's what makes it nice. Okay, with the C++ strings. Okay, good. So last time I showed you this bank account class, and we talked about it, and I challenged you to write this class yourself without looking at the book or anything anywhere else. And I told you that I bet you are going to have problems with the syntax or with the declaration of the objects. Did anybody try it? And I'm sure some of you did. What kind of problems did you see when you try to implement this class yourself? What kind of problems you run into? I just wonder. So Ozan, what did you get when you are writing? What was the most confusing thing, or what was the thing that you did not get right when you write it?
Can I answer?
Sure, yeah.
So it was a syntax. I'm not accustomed to it. And
So,
Akbar is always forgetting how to write.
so syntax is new. It is difficult to remember, right? Is that what you are saying?
Yes.
So yeah, that's one thing. I mean, it is simple, but it is different. I mean, it is different than C. You know C, and you have written thousands of lines of C code, but when you come to C++, writing a class, even though it is difficult, it is similar to writing structs. It is different. So without practice, without writing the same thing over and over again, you won't remember how to write those, and it will take some time. So my suggestion is just try to write your classes yourself, and whatever I am telling you, I am teaching you, just try to repeat the same thing yourself using your compiler. Better yet, maybe you should write it on a piece of paper, because your exam will be on a piece of paper. Okay, so Ozan Argut says it was long time ago, but I don't understand what the binary scope resolution operator is using for. Maybe he's asking a question, I don't know. Okay, and it says that bank account double and bank account int double is mixable. Well, that's not. I mean, I think you are not answering my question. And are you making a point? Anil says that syntax errors and the number of constructors. Lots of syntax errors. I mean, when you see the syntax errors, if you can figure that out, that's fine. But if sometimes you cannot figure it out, sometimes it doesn't make any sense, and you need to go back to the book and see how the things are done. Okay, so again, do the same thing. I mean, whenever I teach you something, try to use it at home on your computer, and you will see that sometimes you say that, yeah, I got it. Sometimes you say, oh no, I missed this part. Sometimes you will say, I understand how the things work, but I don't know the syntax. Okay, so all of them should come together. You should understand the main topic. There are many problems with the object-oriented programming when you start doing the object-oriented programming. The first thing is you need to understand the main idea, why we are doing the object-oriented programming, why there are classes, why there are constructors, why there is information hiding. Other than that, okay, once you understand this, how can you implement these ideas in a programming language? And then finally, how you can do this in C++. Each phase has their own difficulties, okay? So then, and without completing each phase, you won't be able to understand the whole thing completely. Okay, so the next one is this one. Next topic is this. Class type member variables. What do we mean by this? Maybe before doing this, I should talk about these UML diagrams. UML diagrams, unified modeling language, UML diagrams. Okay, UML diagrams are very nice ways of expressing our software design without writing any code. Okay, and UML diagrams provide us a way of specifying our classes. Okay, you don't write a C++ class, but you just draw this nice shape. You will say, this is my bank account class, and with the bank account I have my constructor, and it takes two integers. You may specify the other constructor and maybe a get dollars function which returns a integer, and these are all public maybe. And then in my second part I have my private dollars, which is an integer, and cents, which is an integer, and rate, which is a double. As you see, I did not write any code. I said that these are my functions, and these are my data members. Maybe inside my functions, remember I have my private fraction. I don't remember. I think it was fraction. I think it received a double and it returned a double. Okay, so this is a class diagram of UML diagrams, and this is how we represent classes without writing any single line of code. Okay, this is a standard. Okay, C# people, they represent their classes like this. Java people, they represent their classes like this, and C++ people, they represent their classes like that. It's a universal language. It's a universal language shared by many people of object-oriented world. So many times I am going to use these diagrams. And if you like, there are many good UML class diagram. I think there was a nice tutorial about it. UML class diagrams. Okay, see, there is this shape class. Okay, these are the operations. This is the length. Okay, sometimes with the signature, without the signature, I use this notation, I guess. Length is an integer and it is private data member. And these are two member functions. These are public, not private, but public. This one returns an integer, this one returns void, and it takes a n. Okay, so these are the standard ways of, again, specifying the classes. You read them. UML is not about classes only. UML is about classes and some other software design tools, and you will see about them, I think, in data structures course, also in your object-oriented, in your software engineering classes. Okay, so let's go back and let's talk about let me move this out to this position, and let me move this out to upper corner. Okay, let's talk about class type member variables. Okay, class type member variables. What do you mean by class type member variables? Let me show you the code first, and we will come back to this discussion. Okay, remember our day of year class? This is our day of year class. Constructor, input and output, get month number, get day. And it looks like input is a mutator, output is a accessor, get month number is an accessor, get day is an accessor. So only input is the mutators. Test date is testing the date. Okay, let's look at the implementation of this day of year class. Day of year class is here. Okay, day of year class takes the month value and day value and do the initialization and call the test date. If the test is okay, then we will be done. Otherwise, I will do the exit one. And output is like that. Input is, I think input is, where is my input? It was not implemented. Okay, this is not a complete class, but you know how it works. So the interesting thing here is, in this code, is not the day of year class, but it is holiday class. Okay, we will have a class named holiday, okay, to represent the holidays. such as 23 Nisan or 19 Mayıs. Okay, so or 29 Ekim. Doesn't matter what holiday it is, but for holiday we will have two data members. One of them is day of year. We say that if it's a holiday, then it should have a day of year object inside it. Okay, day of year date. And the second data member is parking enforcement. On that day, 23 Nisan, on that day, can I park my car on the street without paying any money? Okay. If it is true, then in this case, if parking enforcement is true, then that means that I cannot park it. If it is false, then I can park it. Okay, so holiday constructor says that to be a holiday, I need these three pieces of information: the month of the holiday, the day of the holiday, also the parking enforcement. 3 things, and it has an output. It has an output function. It's a very simple class, but although the class seems simple, it is using objects of another class inside it. The class seems simple, but objects of another class inside it makes it interesting for us. That's why we are talking about this class type member variables. Okay, so this holiday class has a class type member variable, which is this day of year object. Okay, well, this should not come as a surprise for you, but it's a new thing. Until now, we did not use any objects as our class members, data members. We have used the simple types such as the integers and doubles and characters and etc. But now we are using a day of year object as a class member. Okay, and this is how we use it. Holiday. Okay, February 14th. On that day, it's a holiday. Okay, February 14th, and on that day the parking is enforced. You may not your car on a street without paying. You have to pay. Okay, and this is how you write your holiday classes, functions. Constructor, no parameters. It says that, okay, if I am the constructor with no parameters, this is, let's skip to line 44 first, then we will come back to this no parameter constructor. I am the constructor that will take 3 parameters: month, day, and enforcement. Okay, but I will pass this month and day to this date. It is interesting. What is date? The type of date is okay, day of year, and day of year constructor takes 2 parameters. I am passing these 2 parameters to my day of year object. Okay, it looks like this initialization section of my constructor is actually calling the constructors of my data members. It looks that way, and that's what happens actually. So the parking enforcement is a boolean. I just pass this information to this boolean. But date is a day of year object, and I pass month and day to the constructor of my day of year object. And line 46, this is a very nice comment. It says that it is intentionally empty. I did not forget about writing code here, okay? I left it empty intentionally. That's a very nice comment. We usually do it that way, okay? Otherwise, reader of this class might think that I forgot to put some code in there. And no parameter constructor, again, it calls the date constructor with 1 and 1. January 1st, and the parking enforcement is false. On January 1st is a holiday. Again, January 1st is a holiday, but on that day, since everywhere is closed, parking is not enforced. I may park my car anywhere I like without paying. And let's look at this output implementation. So the output implementation says that if I am a holiday, then I need to have a date, right? Day of year. So for the day of year, I don't have to deal with the complications of how the date is printed on the screen. Instead, what I do is I just call this output function of the date data member. Okay, call the output function of the date data member, and that will handle everything for me. And after that, I need to take care of this parking enforcement. If it is true, then parking laws will be enforced. Otherwise, parking laws will not be enforced, will be printed. So the parking enforcement, I have to handle it myself, but for the date, I know that there is an output function already implemented, and I am using it. Oh, okay, good. Okay, and the rest is, I guess, the day of year class. Yeah, the rest is just day of year class. Okay, this is how you do the data member. Have another object as your data member. If I go back to the slides, and if I use my UML diagrams, okay, this is my holiday class. For my holiday class, I have my constructor. My constructor takes integer, and a boolean. Okay. Of course, this is a public constructor plus another constructor doesn't take anything, holiday doesn't take anything, and I think there is an output function, and it is just void, right? And when it comes to the data members, there is a there is a date data member. Its type is day of year, and I think there is a parking enforced. It is boolean. Okay, so this is the UML diagram of my new holiday class. Let me rewrite this so that it is more I am not claiming it's going to be readable, but it's more readable. Holiday. Okay, good. So day of year is part of this class. Sometimes I do this. Where is my day of year? Oh, I don't have day of year. Day of year. Okay. Sometimes I do this. Diamond shape. Okay. I didn't write the whole details. Okay. So I have two class UML diagrams. I am saying that I am using the objects of this class inside this class. Okay. And this is called composition. Okay. Composition is a very important object-oriented programming language technique. When you do the composition, you use members of other classes inside your class, and that's what you're going to do with your homework number 3 actually. When you do the composition, you are reusing your day of year class in another class. Software reuse. Remember software reuse? Object-oriented programming is very good for software reuse. With the holiday class, see, this holiday class is a very simple class. Where is my holiday class? Yeah, it's a very simple class. It is just, let me try to see how many lines of code. Okay, it's just line 21 to 56. It's like 30 lines of code, maybe 35 lines of code. Okay, including our main. Very simple class. Is it simple? Because it is simple because it doesn't have to think about how I input a date, how I validate a date, how I print out a date, right? It just thinks about, other than the date, what should I be concerned about? I should be concerned about parking enforcement, maybe. That's it. Okay. Software reuse makes my classes simple to design and simple to implement. If I have written my classes in a reusable way. I guess Yağız has a question. When we say day of year, X is memory allocated for X automatically like we do with malloc, or if we can free memory? I think he's asking a very different question than what we are talking about, but okay, let's go back and try to answer that one. Yağız, this is no different than, you know what I'm going to write, right? Why can't I? Okay. This is no different than saying integer I. Saying integer I and day of year X is exactly the same thing. As soon as you execute this line in your memory, there will be a position for I, and inside that I, you may put an integer like this one. When you say day of year X, okay, this X will be somewhere in the memory, but inside X, there will be a position for month like 12 and day like 30, right? Okay, so back to your question. Can you free the position of I in C? Answer is no. Can you free the position of X? Answer is no, because it is the same thing. It is the same thing as declaring a variable. Okay, no different. Okay. If you like to do memory allocation, then you need to use those special functions like malloc, okay, and if you for integers, okay, and if you like to do the memory allocation for day of year object, then you're gonna do malloc. But in C++ we don't like that malloc function. We have a new operator, and we are gonna see that operator later. Hüseyin Ömer, nobody knows about inheritance. What is inheritance? I don't know. Nobody knows about inheritance. Okay? You ask me that question at the end of the semester when we talk about inheritance. And there is a big difference. In fact, there is no similarity. Okay, so composition is important. Why? Because it is a very nice technique for software reuse, and we are gonna try to use composition as much as possible. Actually, we have been using composition with the simple types. Now we are gonna use composition with more complicated types, such as the types that we have created. Mohammed Bedir, if we define a constructor like const, if we define a constructor like const, just want to set no, you cannot. I mean, for the constructors, Default arguments has to start from right to left. You cannot skip. Okay, it has the construct with the default arguments. Default arguments has to, let's say this is your function. By the way, it doesn't have to be a constructor. Okay, if this is your integer parameter 1, integer, let's say bool parameter 2, etc. Okay, if you are doing the default arguments, you have to start from the rightmost one. That has to be let's say true. After you did that, you may say this is 1. Okay, this is okay, but you cannot say this. You cannot say this. No, this will not. This is a compiler error. That was the one of the rules of default argument. Okay, good. I think I am out of time for the first part of this lecture. Let's take 10 minutes of break. After the break, we will come back and we will continue our discussion about the classes again. Okay, so let's be here around 11:33. Aleyküm selam. Okay, let's continue. Again, like I said before, composition is important, and we will keep using composition over and over again. Sometimes we will not mention it, but we are gonna use it a lot. And it comes so natural, so you don't mention that it's a example of a composition, but we keep using it. While I am doing this, let me try to, let's say, what happens when we do the holiday.
Sure, I have a question.
Sure.
We can't hear you, Yusuf Hocam.
Okay, you have a question? Just ask your question.
Yes, when we declare class in other class, the memory allocated at the memory allocated when we declare or later.
Yeah, okay. I was just going to answer that actually. Yeah, that's a good question. When I do this holiday age, what happens? Okay. When I do integer I, this is what happens. When I do holiday age, let's see what happens, okay? So let me do this for the 23 Nisan, I think January, February, March, and April, okay. 4th month and 23rd for 23 Nisan, right? Oh, okay, and parking enforced is 23 Nisan. Can I park my car there? No, I think the parking enforcement is true. If I park my car there, I have to pay, right? So this one says that, okay, I have two fields. One is a Boolean, that is the parking enforcement is a Boolean. It's going to be true. And the other one is a day of year object, okay? There should be a date. It is a day of year object, right? Day of year. And inside that, it will be 4 and 23. So this holiday object will be like this. Usually I put this, right? Okay. Inside my holiday objects, there is one day of year object and there is one Boolean object. Okay. The value of Boolean is this and the value of day of year is this. So when is this object is created? When is this object created? It is created when I call this constructor. Remember, when I call that constructor, that constructor immediately calls the constructor of the date object, whose type is day of year, and I pass these two values to that constructor. Okay? Did I answer your question? Who asked that question?
I asked.
Okay.
Did
you get the question?
Okay, I understood.
Okay, good. So that was a good question, and I was already trying to answer that question with this picture. Okay, so size of holiday, just check this, okay? Write some code to see what is the size of day of year and what is the size of holiday. You will see that the size of holiday is you're gonna see that is going to be size of day of year plus size of Boolean. Okay. Oh, well, maybe I should put a sign there because sometimes for the optimization it might be a little bit more. We don't know, it might change, but it is definitely larger than this. Okay, it's definitely larger than that. So inside the objects you are keeping the other objects, but holiday class as the implementer of the holiday class, okay, All I do is I just write my constructor, I just write my specialized functions, and I don't care about how the date is represented. You see in the holiday code, do you see anything about the validity of the date? No, right? But I know that the date is valid. Why? Because when I call this constructor, that constructor makes the validation. Okay. When I do this output thing, I don't care about how the dates are printed out. All I know is that that day of year class is going to handle that for me. So that's the power of the composition. That's the power of the composition. So class member variable types. And I think I have already shown you this with the holiday. We use this one. Remember when we talked about initialization, we said that this initialization is better way of doing things. Okay, this initialization section is the better way of doing the initialization. Well, this is the only place where you can call the constructor of your objects, data member objects. Okay, if you don't do this, if I don't do this, then this is what you have to. This is what you're gonna have to do. Let me go back there. Let me take this out. Okay, and this cannot be empty anymore because I need to make the initialization, and I need to do this set month and day. Okay, and then what? Yeah, parking enforcement is going to be the enforcement. I have to do this. Okay, and we don't like this way of doing things. We don't like this way of initializing things. Can anybody have a guess? I don't like this better than line 45. Line 45 was much better than line 47 and 48. Can anybody tell me why? Think about what's happening with line 45 and line 47, 48. Mehmet Hüseyin, just explain that a little bit because it is already constructed. What do you mean? Use your microphone, Mehmet Hüseyin.
Sir, as I said before, it's constructed on line 44.
It is already that object, day of year object is already constructed. With what values? It is constructed with default values, 1 and 1, right?
Yes.
So when I start executing 47, it means that I have already an object which was initialized to 1 and 1, January 1st. Now I am changing to something else. So why should I construct it with some other values and change it later? Instead, I would do it this way. I would just say, construct it with the right values and don't change the values later. Okay. So line 45 is called when those my data members will be constructed. Okay. These are how you call your data member constructors. This is the constructor of the Boolean parking enforcement. Okay. This is the constructor of the day of year. Okay. If you don't call them on line 45, the default constructors of those objects will be called default constructors. Okay, no parameter constructors. So when line 47 started, the objects are already created, they are initialized, and you are reinitializing them, which is not efficient. So I don't like these two lines. Okay, I don't like these two lines. So instead, I like what the book does. Do it this way. Okay, if you're going to initialize something, initialize it this way. Always, I mean, previously we were saying that, okay, why don't you do it? I mean, this is okay, but we like line 45 better. Now you know the answer. We like line 45 better because line 45 is the position where your data members are created and constructors are called. While your constructors are called, why don't you use the correct parameters for the constructors? That's the idea. Good. Okay, so what Mehmet Hüseyin says is correct. Good. Okay, so I talked about this. That's good. Bank account class, we already looked at it. Okay. And our classes and our objects, okay. First, the class, the difference between class versus object. Okay. Class is like a blueprint. This is a, okay, this is a classical definition, and this is the object is like the home built. Blueprint is in architecture terms, it is plan, bina planı, and home built is the that you are building your home. Okay, if you have the blueprint for a building, eğer bir binanın elinizde planı varsa, if you have a blueprint of a building, then you may build as many homes as you like, as long as you have the money. Okay, so if I have a class definition, the blueprint, I can make as many objects as I like, as long as I have the memory. So we keep saying this all the time. It's a classical example. So class is different than object. Class is different than, of course, object. There is a single class definition, but you may have many objects of the same class. 0, 1, 2, 3, up to your available memory. Doesn't matter. So once you have a class, okay, you will have objects of that class, okay, and those objects could be passed to the functions using call by value, call by reference, or call by pointer. Doesn't matter. Okay, you may have pointers of your classes. Okay, pointers of your classes, and you may point to your class objects using your pointers. Okay, call by value, call by reference. We said that we pass our objects of classes to functions using call by reference. Why? Because with the call by reference, there is no copying going on. Okay, there is no copying going on. The reference of the object is passed to the function. Okay, so since there is no copying going on, the reference is passed, only the reference is copied. It is cheaper if the objects are large. For simple types such as double or integer or boolean, objects are very small. They are like 4 bytes, 1 byte, or 8 bytes. It is small. But if I have class objects, usually they are larger than doubles. Okay, maybe sometimes they are like 1 kilobyte of an object. In that case, you don't want to pass a copy of your object. You like to pass the whole object by reference, so there is no copying going on. Okay, so for the parameter passing of your objects, we prefer call by reference. Call by reference is desirable, especially for large data like class types. Okay, I think I mentioned this before. Now I am mentioning it again. This is what we are gonna do with our classes. This is the way we prefer to pass our class objects. Okay, good. And previously, I think we repeated this many times maybe. For large data types, it is desirable to use pass by reference. But with the pass by reference, if it is not my intention to modify the object, then there is a danger of accidentally modifying my object in my function. Okay, I'm a human being and I can make mistakes. So protect argument, usually we pass them using const references. Okay, we pass them using const references. Let's say I have a function f, it returns an integer and it needs better yet, a holiday object. Okay, age, we said that let's pass this using the reference, but a constant reference. So you're gonna see this picture over and over again. Objects of classes will be passed using constant references. Okay, good. So let's go back to our bank account class. Let's go back to our bank account class and let's try to add some more functions to it. This is our bank account class. I don't want to do this, but for the sake of teaching you some stuff, I want to write a global function. A Boolean is larger. Okay, is larger is going to take two bank account classes. Okay, bank account is a reference B1 and bank account is again reference B2, and it will return, I wish I, oh okay, I found it, 7 and 0, don't forget about it. Okay, I will do this, return B1 dot, how did we do that? Get balance, yeah, okay, get balance. If it is greater than B2 dot get balance. Okay, so this is good. Tell me what you didn't like about this. Tell me what something that you didn't like about this function. Well, first of all, it's a global function. I don't like global functions. Just for the sake of the discussion, I'm writing a global function just to demonstrate some stuff. Other than the global function, there is something missing with this function that we always do. I just told you. I forgot about these consts right here, const and const. Okay, yeah, and it's just exactly. So other than global function, this is a nice function. Okay, this is a nice function. We don't like globals, but just okay, let's ignore that being global right now. So if we don't like this one being global, so how am I going to use this? I have two accounts. When I say if is larger account 1 comma account 2, yeah, and cout, I would say first account is larger. Right? So this
Hocam,
is a,
yanlış yazdım.
what?
Account 1'e account oldu hocam.
What? It's talking in English. What did you say?
Second parameter is wrong in 73rd line.
Like that. Okay, thank you. Is that correct now?
Yes, I guess.
Okay, good, thank you. So this is how I write it if I have the global function. So we don't like the global functions. Let's convert to a member function then. Okay, if I convert this to a member function, I am going to use it like, account one dot is larger, right? Is larger than account 2. And I am going to repeat the same thing here. Okay, so I don't like line 73, 74. I like line 76 and 77. So if I like these 76 and 77, let's write the is larger function as a member function. So let's write it as a member function. Here it's going to be a Boolean is larger const. I'm going to take another one, right? Another bank account object, and this time I am going to call it other. And let's implement this stuff here. Tell me, what should I write? Return. What should I write here now? Return get balance is larger than, we need to use const. I am using const here. Const, okay. So is larger, okay. Get balance is larger than the other dot get balance. Good. So this is how I implement it as a member function. So this member function and this global function, they behave very similarly, but I like the member functions better. Why? Because this is the rule of encapsulation. Put the data and all the functions that work on the data in the same capsule. Okay, so let's look at this code now. This code says that I am not going to modify B1 or B2, right? That's what this code says, this global function. This one says that I am not going to modify, okay, I am not going to modify the bank account named other. But what happened to this B1? I mean, I have two const keywords in line 65, but only one const keyword in 45. This 45 doesn't talk about my object, okay? This is larger says that I am not going to line 78, line 78. This one says that I am not going to modify account 1 nor account 2. But line 81 says that I am not going to modify account 1. How about account 1, account 2? Okay, how about account 1? Is larger can modify account 1? Yes, it could. Why? Because it's a function that works on account 1. How can I make sure that this is larger function, the member is larger function, is not going to modify account 1? This is how you do it in C++. This is a new notation now. You put a constant here, okay? You say that this member function is larger is a function that takes a bank account object as a constant reference. It's not going to modify the other object. Also, it is not going to modify, the object itself either. Okay? The object itself will stay the same. It will not modify it. It makes a promise. Okay, so this const here, I mean this const, how can I make this? I mean, I don't know. This const corresponds to this one, and this one corresponds to this one. If you like to make a correspondence between global function and the member function. Okay, so that's the meaning of const at the end of the member function. What is the meaning of this const here? If I put a const at the end of this global function, line 65, what is the meaning of this const here, line 65?
The function doesn't change any class variables.
Okay, say it again.
The function doesn't change any class variables, member variables.
Class variables of what? Of what class?
Of its own class.
What is the own class of is larger? It's a global function. Line 65 is a global function. It doesn't have a class. So what is the meaning of line 65? The const here at the end, what is the meaning of this const at the end of 65?
Error.
It doesn't have a meaning. It's a compiler error because this const could be used only for member functions, not for global functions. Okay, it is meaningful here at line 45, but it is not meaningful at line 65. So it's a compiler error. I am going to erase it. Okay, so that's a point. So I have a question. Ryan has a question. But if we have more than 2 accounts and have to compare them between each other, should we still use the member function, or global is more preferable in this case? Global is never preferable. Sometimes we use globals just because we have to. Okay. If you have, what do you mean? I mean, how can you compare more than 2 accounts? I mean, if you compare 2 accounts, one of them is larger than the other one. How can you compare 3 accounts? I mean, if you're gonna compare something like this,
comparing in order, like
const, maybe
first and second,
maybe
first and third.
bank account other 2. Maybe what you mean is if my balance is larger than both of them, is that what you mean? And get balance is greater than, this is what you do it. I mean, if you, what you mean is I like to compare myself with 2 other bank accounts, and if I am greater than both of them, I am going to return true. If this is what you mean, yeah, this is what you do it, how you do it. Is that what you mean by more than 2 accounts? I don't understand what you mean comparing in a row.
Like first and second, first and third, second and third.
Just write me the code, how you would use that function. Just tell me how you would use your function. Are you going to say account 1 dot is larger? Just how we're going to call that function?
Exactly the way you did, but I will use it multiple times for different accounts.
Did I answer your question, or
Actually, no, but never mind.
I did not understand your question actually. I mean, you are saying that this line 45 is line 45 not answering your question?
No.
So ask your question again.
If we have like 1,000 bank accounts and I want to compare any account to any other account in
Okay.
any time, should I use member function or global
Well-
function?
Well, in that case, what you're going to do is you're not going to take a you are not going to take a bank account object. You are going to take an array, right? In this case, you are going to take a
Yes.
pointer. If I can find the okay, and you are going to take the size, right? And in a for loop, you make your comparison with each of them one by one, right? And
Okay, thanks.
since you are taking it, you would say that I promise I am not going to change the elements of this array. You put a const at the beginning. Okay. So
Okay.
let me erase this part. And anyway, so whatever. Anulmert has a question. What happens if we use const and don't use reference? It's like a constant reference. If you don't use reference like this, line 41, I have a add function before that I have written. That means that you are making a copy of your object. You are not using call by reference, but call by value. Okay? You are saying that I am making a copy of the original object, and I promise that I will not change this copy. You could do that, but that beats the purpose. I mean, the reason why we are using the reference is because we don't want to make a copy. I mean, if you make a copy and you modify your copy, nobody cares. Okay? So you are saying that I am going to make a copy and I am not going to modify that copy, but nobody cares about your copy. So usually, line 41, you are not going to see anything like this. I mean, almost never. Okay? If you see a const, there will be a reference in there. Okay, Dervish Ali, I think it doesn't mean anything in this case. Dervish Ali, are you referring to Anil's question or Ryan's questions or all the things that I am saying? I don't know. I said it on line 65. So I missed the time, so I don't remember what I said about 65. Oh, you mean the const? Okay, maybe. Okay, good. So let's go back to our slides. Okay, let's go back to our slides and let's talk about this const parameter modifier again. Const is used two ways. Okay, one is for the parameters of a member functions. The other one is for the member function itself. Okay, so we said that in our bank account class, our function output is a const, get balance is a const, get dollars is a const, get cents is a const. Why? They are not modifying the object that they are working on, right? They all getters, they are all accessors. Okay, so we mark our accessors or getters with this const keyword. Okay, and this is called the principle of least privilege. We are saying that I am restricting myself as a function. I am restricting myself, and I am saying that I am not going to modify this object. Let's go back and see this add thing. Where is okay? Is this function add 41 const or let's look at, okay. Line 11, should this function be a const or not? Line 11. Should I put a const in here or not? I should not. Why? Because constructor, as the name implies, this is for constructing an initialization. How am I gonna initialize the object if it's a const constructor? Okay, so const constructors are out of question. You cannot have a const constructor. Constructors cannot be const. Okay, so line 14 cannot be a const. Line 18 cannot be a const. Line 22 cannot be a const. How about update? Is this a const function or not? Line 25, is it a const function or not? Well, let's say this is update. Update means that I am going to modify my balance with the amount of interest. That means I'm going to modify, so this cannot be a const. Input cannot be a const, but this is going to be a const, right? This is going to be a const. And this is going to be a const. This is going to be a const. Set balance cannot be const because it is changing the balance. Set rate cannot be. How about add? Is add a const function or no const function? Is function add, line 41, a const function or no const function?
No.
No. Why? Because it modifies something? No. Well, does it modify anything? Do you guys remember the implementation of add? Where is add? Did I implement it? Let's look at the, yeah, add. It says that I have a temporary object. Oh, it, okay. Where is my, okay, here is add. Should I put a const in here or no const in there? Let me, okay. So it looks like it is modifying this temp object, and temp is a temp object, and temp object is, I am calling the set balance, and set balance is modifying the temp object. In that case, I cannot put a const in here. Okay, what is your answer? Should I put a const or not? It modifies that, it uses set balance, right? It uses set balance. Set balance modifies the object.
But it's
Yes.
the created temp variable is not a constant variable. That's why maybe we can put the const there because we are just returning it after we modified it.
Temp is not my current object, okay? My current object, when I say a1.a2, okay, when I say const, I am referring to a1. When I say a1 dot add a2, okay, a1 add a2, this const here refers to a1. So inside this function, I may modify any object I like, no problem, as long as I don't call set balance function on my object. So this add function is a const function. I should put a const in here. Why? Because I am not modifying my current object. I am not modifying my current object. That's why you see this one? This global function, it takes two consts, account1 and account2. It doesn't modify neither of them. It modifies this temp object. It's the same here. I should have two consts in there. Okay. So good. I put a const at the end of this add, and is larger again a const, and Okay. Is a const too. Rule. Okay, and you should know, you should justify this rule, or you should understand this rule. These are const functions. Okay, these are const functions. There are two types of functions in my class. There are const functions and non-const functions. Const functions and non-const functions. This is a non-const function update. Okay. Input is a non-const function. Of course, our constructors are non-const functions, but output, get balance, get sense, these are const functions. Rule is this. Your const functions cannot call non-const functions, right? This is understandable. Your const functions cannot call non-const functions. I may not call inside. Let's see. Let me go to a const function here. Let me go to a const function. Okay. For example, get rate. Get rate cannot say input. If I call by accident input, the function input, doesn't make any sense, but let's say if I call this function input in my get rate, the compiler tell me that get rate is a const function, but you are calling a non-const function at line 189. That you cannot do that. But the opposite is not true, okay? My non-const functions can call the const functions, of course. Okay? My non-const functions, of course, can call const functions, because on a non-const object, I may call const functions because I am not going to modify them. It is up to me to modify or not modify. Okay, so that rule is important. Const functions can call non-const functions. Opposite is not true. Good? Opposite is not true. Okay. So, use of const, all or nothing. All or nothing. I think the book has an example here. Not this one. Is this? Yeah, okay. The book gives an example that uses consts nicely. It says that all of these are consts. Okay. And by the way, the book, how about this? This is a very good discussion actually. Remember the private functions that I did not like before? The book made them const. Do you remember their definitions, implementations? Dollars part returns just the integer part of the amount. Cents part returns the decimal part of the amount. Round is just rounding the. So we said that these four functions, we don't like them because they are not working on the class data. All the data that they need is inside their parameters, but we don't want to write global functions. That's why we put them inside our private, so nobody can have access to them. Our customers will not see them, etc. So, should I make these functions const or not? Should I make these functions const or not? And what happens if I make them const and if I don't name it? It looks like this question is irrelevant because I am saying that these should not be part of the class, but again, man, I have to ask this question. The book makes them const. The book makes it const because it is nice to be const. I mean, is it okay if I don't make them consts? Or do I have to make them consts? Well, I mean, I agree with the book that they should be const, but do I have to make them const, or it is nice to be const?
Nothing needs to be const.
They need to be const. Why?
I mean,
okay.
nothing needs to be const. It's just
No.
optional.
Well, yeah. Well, I mean, if you are not using, if I have all of my accessors const, like line 28 to line 32, if I have them consts, if I mark them with const, should I make these private functions const? Mustafa is saying something. Mustafa explained that other const functions call them. Okay, what do you mean? Mustafa, that's a good answer, but you should explain it a little bit more. Use your microphone.
Sir, other constant functions call only constant functions, so they must be constant functions.
Exactly. Remember, who is calling this dollars part? Let's look at this output function. Output is a const function, right? And output is calling. Well, it doesn't call the function itself. It is directly accessing the. Let me try to find it. Let me try to find the exact. Not that one. That one. What? Where is my? Oh, not this one. Okay. This output doesn't use the accessor, but let's say get dollars. Okay. To get the dollars, okay, this output is using get dollars and then get cents. Since get dollars is a this is not a good example. No, this is not a good example. Let me try to find an example where it calls this dollars part. Okay, let me find this dollars part. Is anybody? Dollars part inputs, set balance. Nobody is using cents part. Nobody is using dollars part. How about the round? Yeah. See, this cents part function is a const and it is calling this round. If round is not a const function, I cannot call it. Why? Because within the const functions, you may not call non-const functions. Okay? That's why my round and all the other helper functions has to be const functions because they are not modifying anything, right? They are not modifying anything anyway. Since they are not modifying anyway, in fact, they are not accessing anything. So it makes more sense to make them constants because that way I may call them anywhere I like from a non-const functions or const functions. Okay. So Mehmet Hüseyin has a question. It may change global variables, so we should make it const. I don't understand the explanation. Okay, it may change for the global variables. We should make it. Oh yeah, maybe he means that it doesn't change any class related variables, object variables. So maybe we should them. I mean, it is not nice. Okay, it is not because it is nice to have these functions as const. We have to make them const because we are going to call them from const functions. Okay, we are going to call them from const functions. Well, it looks like I am out of time. Tomorrow morning we will continue from this point, and I think I assigned your second and third homeworks. Second one is a simple one. Third one is, it's not that difficult, but it is going to make you write some classes. And I think that's it for today. Tomorrow morning we will continue. Okay. See you tomorrow.